Thank you. I'm Flynn. I am a tech evangelist with Buoyant. This is how you reach me. The best one's probably Slack, but you can also find Buoyant.io on Twitter, or you can find me on GitHub if you want to do that for some reason. I am a tech evangelist with Buoyant. That means that my job is to make sure that everybody out there knows the point of Linkerd, which is arranging it so that every single cloud native developer on the planet has the tools that they need to do really good, highly secure, reliable, observable cloud native apps, and to make those tools freely available. And also my role is to try to make sure that everybody also has the information and resources they need to be able to do that. Hence this workshop where we're talking about observability. Observability is kind of the classic cloud native problem in a lot of ways. You're running things off in a cluster, somewhere, you don't necessarily know where. You don't have things right in front of you that you can go poke at. Seeing what's going on inside your cluster, especially when things are not going well, can be exceptionally difficult. Service meshes as a class are pretty well positioned to be able to help with this, since they get to watch what's happening in between the different pieces of your app. Linkerd in particular has two pieces of it that we're going to talk about today, which are very, very good at helping with this. The first one is the Linkerd Viz tool, which is literally just a tool that's about looking into your cluster and seeing what's going on. So it can show you things about the topology of the different apps in your cluster. It can show you statistics like how many requests per second, how well things are working. We're going to show this in much more detail shortly, but that's the first of the two. The second of the two is the service profile CRD, which is a way that you can talk to Linkerd about how to watch your application for things that are going on, and also how to do some management of your application to try to help out when things are not going well. On the watching front, one of the first things it can do is it can say things like, okay, if you see a delete request to any URL that looks like this books regular expression thing, then it can take all of those, and instead of forcing you as a human to read delete books5 whatever.json, delete books6.json, and then having to go through and kind of mentally keep track of all this stuff. Instead, Linkerd can take all of those requests, bundle them together under just books id.json, so that you, the human, see the collated result rather than having to do all that work on your own. The really cool thing about this, though, is that once you have a service profile in place, Linkerd will be continuously watching all of those requests in the background all the time, keeping longitudinal stats about them. So if something is going on, you can then later go back and look and try to see what's up and what was happening without having to constantly be sitting there in front of a dashboard looking at it. And with that, the rest of this is going to be a live workshop. So everybody buckle your seatbelts and wish us luck. All right. So
for folks in the audience, if you ask a question in the workshops channel or in the Slack, I will interrupt Flynn periodically and just let him know what's going on. So please feel free to make this as interactive as you like. Sorry about that, Flynn.
No, definitely. It's a good reminder. All right. A lot of the time when I'm doing workshops and things like this, I will tend to do them on local K3D clusters. This time around, I am using a cluster out in the cloud from Civo. Mostly that's so that if there are any of you who have not had a chance to go through and set up a cluster to follow along, you can actually point your browser over to the dashboard on my cluster, and you'll be able to kind of get a better sense of what's going on as well. But hopefully you will set up your own clusters and follow along. So the first thing I'm going to do is walk through how I set this cluster up and how you can do it on your own. Step one, kind of, silly to say it, but there you go. The first thing you do is you need to kind of have a cluster, right? And if I were doing this with K3D, I would just run cluster create. These are important. I have this set up to use an ingress rather than doing a bunch of port forwarding. This is a part of that. It's also worth telling K3D not to run traffic because we're not going to use it. It'll just get in the way. So after doing that, you literally install Linkerd just from the quick start. There's nothing special about the way we do this, with one exception, which I'll get to in a minute. And you'll know that that works when you get to the end and it can go through and run Linkerd check. And at the end, you get the green check mark. You'll also need to do Linkerd viz install, which I may have forgotten to show here. Okay. After that, the one gotcha. I said a minute ago that I was going to be using an ingress to do this. The point of the ingress being able is that we have it set up to do just host-based routing, so you can talk to a particular host name and get to see particular chunks of this application. And it turns out that the Linkerd viz dashboard doesn't really like to do that out of the box, because setting things up this way is kind of a terrible idea if you're not doing a workshop. First, Linkerd install is going to generate its very own Linkerd certificates, which you then won't have access to. So when they expire, you'll have to go through and generate your own. Second, we don't have authentication on the dashboard. We rely on you to put that there. And the way I'm doing things is going to let all of y'all directly into the dashboard without any authentication. Bad idea for production, works out fine for a demo. So what you have to do to make that work is change a particular setting in the web deployment for Linkerd viz, which is this one. All the way down here, you'll see this enforced host line. That normally has a much more specific set of constraints on it. And for this one, I'm just going to say allow everything. All right, so I've already done that. That's why it says there were no changes made. Like Jason was saying, if you have questions, go ahead, toss them into the Slack so we can get to them. The last bit here is we're going to install the demo apps. In this case, we have two demo apps. We've got the Emoji Photo demo and the Books app demo. And then we're going to set up an ingress running. I'm not really going to talk much about how I've set up the ingress. The important thing is that it's setting it up so that we can use host names to get there, like I said. And in this case, what that means is we can go through here and talk to, hey, Jason, do you want to Slack these actually? If you talk to emoji.civo.59s.io, then you'll get to the Emoji Boat app. That's our usual. Oh yeah, sorry, Tariq, there will be all of this will be available on GitHub. You'll be able to see all the scripting and all the details.
So
And
we'll share that in the workshops channel after the Slack. And then Joaquin asks if the ingress to mesh is using MTLS.
And in fact, it will be right after I finish showing this stuff on a browser. This is the Emoji Vote application where you get to go through and vote for your favorite emoji and see the leaderboard. I should point out there is something going through and generating traffic on this. I am not just sitting here clicking on emoji over and over and over again. The Books app at books.civo.59s.io is an application that just lets you go through and look at some books or look at the authors, and there you go. It's pretty much what it does. Finally, this is the Viz dashboard, and we'll come back to that shortly. But all of these are set up just so that you can go to the host name. There's no authentication. There's no other requirement. It'll just work. And to Joaquin's point, if we come back over here, the last step of all of this is to inject the ingress into the mesh so that it is in fact using MTLS all the way through from the ingress all the way into the apps. Everything is in the mesh and MTLS is everywhere. All right, Jason, what do you think? Make sense so far? You got any other questions?
It's making sense to me, and I don't see any new questions in Slack. For those that are out there, I'm sending you the links that Flynn's putting up right now, just so you can go play with some of these apps live.
And again, let me point out one more time, this is, like I said, this is good for a workshop, not the way you want to do this in prod. All right, so with that background and that setup, we're going to switch back to my Civo cluster and that's actually running out there to show you what it is looking like. It's a single node cluster. You can see, yeah, we've got the books demo, we've got the emoji demo, We've got the ingress, and most importantly, we have Linkerd and Linkerd viz running. And we know that they're running because we can run Linkerd check on this cluster, and it'll go through and do the right thing. At the very end there, you see that we get a green check mark all the way across the board, so we know everything is working. All right. Now let's imagine that it's Friday night and something is wrong with emoji vote. It has been my experience that when people say something is wrong, they very rarely tell you exactly what's wrong. It's just this nebulous, oh my God, the world is coming to an end panic. So what should we do about this? We're going to start by looking at it with the command line. The first question is just, we know there are multiple namespaces in this cluster. We know there are multiple apps running. So the first thing to do is just ask Linkerd viz, hey, how are things working? And we can pretty immediately see that emoji vote is not showing the 100% success that we would really like to see. That's probably a problem. And foreshadowing, we can also see that about Booksup, but we'll come back to that in a bit. So we know that something is wrong in emoji vote. We can look a little bit deeper to try to get a sense of what is wrong. We'll start just by breaking out by deployments within Emojiboto and seeing if any of our deployments are in particular reporting unhappiness. This lets us immediately see that the emoji deployment and the vote bot, they're both completely happy. So the voting deployment and the web deployment, those are the ones where we seem to be having some trouble. Eric is asking, there we go. Yeah, broadly speaking, Linkerd viz is going through and grabbing a bunch of stats that it's keeping track of, and Linkerd viz stat on the command line is reaching into the cluster and asking for the information. All right. So given that we've seen that voting and web are having problems, we can go, all right, well, let's go take a look at the web deployment. We'll start there. It's sort of the front end. And when we look at that one, you'll notice I ran viz tap, and this is going through and showing me, sorry, viz top. This is going through and showing me the topmost requests, the top most common requests coming into the web deployment. And we can look through and see that most of them look like they're doing okay, except for we've seen one request to vote for a donut, and that one failed. That's a little bit interesting. It makes me wonder whether we're going to see another one. If we see another one, is it going to fail too? All right, well, let's, oh yeah, so. Right, so all of the votes for donuts seem to be failing. So that's interesting. Let's take a look at the voting deployment and see if it looks like it's running into separate problems, or see if it's just this donut thing here. So here again, we're looking at the most frequent requests in real time coming into our voting deployment. And the first thing we see is that a vote for a donut fails. Okay. So at this point, we could decide that we should just go and hand this over to the developers and say, hey guys, voting for a donut is having problems. But rather than that, let's see if we can go a little bit deeper first. One thing we can do is we can start by, instead of running viz top, we can run viz tap, where top goes through and collects all of the things that are happening and then tries to show you the most frequent things happening. Tap just shows you all of them in real time. Yeah, go ahead, Jason.
Pause you for a second. Leonard asks, does this also work with non-HTTP protocols like gRPC? And I'll let you answer that. But just for a heads up, if you take a look at the application on the back end, the connection from web to voting, in this case that Flynn was tapping, was a gRPC call. So, but I'll let Flynn go into a little more detail.
So there are a couple of things to know there. The first one is gRPC actually runs on top of HTTP2, but the other one is that, yeah, it's the protocols that Linkerd can handle natively, including gRPC. What we're looking at are requests here, not connections. Does that make sense? So we do get to see individual requests, whether they're HTTP or gRPC or, And like I was saying, Linkerd viz tap will show us all of these things just as they go in real time. You'll notice that showing us a little bit more information than top did, because top is trying to show us a nice, neat, short thing. In this case, we get to see the method, we get to see the path, we get to see the success rate and such. And I accidentally hit return before I was ready. Sorry about that. But we did get to see that there was a vote for a donut that failed there. And so let's just go ahead and take a look only at the votes for donuts to see if they're all failing. Unfortunately, since I told it I only want to see the votes for a donut, I have to wait for votes for donuts to come in. And so that might actually take a little while. But okay, there we go. We got two quickly. And an interesting thing here is they're all showing a status of 200, but they're all also showing a gRPC status of unknown. Worth pointing out, unknown does not mean that Linkerd doesn't know what happened with gRPC. Unknown is a specific gRPC error, meaning something went wrong, but the gRPC layer can't tell us anything more about it than something went wrong. So we actually know that there is a problem here. And we know that it seems to be affecting all the donuts, and it seems to not be affecting anything else. This is obviously troubling. Donuts are kind of popular. We can look a little bit further in there, even that, by running exactly the same command, only tacking -o JSON onto the end. And here, instead of going through and seeing that little summary, here we get this huge JSON block where we get to go through and see individually the request. So we can see this is a request. We can see that it is coming from the deployment, from the voting deployment, from the web deployment to the voting deployment. Wow, I cannot talk. We can see that the path is the donut. And if we scroll down a little bit, then we can see what the response was as well. In the response block, here we get to see broken down a little bit more. The status is a 200, the gRPC status is 2, and this is an error. So at this point, we definitely have everything we need to go back to the developers and tell them, hey guys, something is wrong. Every time anybody votes for a donut, the gRPC layer fails. Please go take a look at that. On the other hand, that took a little while. The reason it took a little while, as I mentioned, was that we kind of had to sit there and wait for people to go and vote for the donut and wait for it to fail. It would be a lot nicer if we didn't have to wait for it and if the system was just keeping track of what happened with the donuts for us, no matter what else was going on. That, as we mentioned earlier, that's what service profiles are for. So we also mentioned the emoji service, this whole emoji vote app is gRPC. gRPC means protobuf. And one of the things that Linkerd can do is actually just read the protobuf and then write us a service profile for it.
Flynn, do you mind sharing a little bit about, you talked about service profiles a few times. What's the intent of that object? Like, what does it do for Linkerd?
It lets you do two separate things. The first one is it shows Linkerd, it tells Linkerd how it can watch your application. It gives Linkerd some information about what kinds of things are likely to be going on. It also tells Linkerd that the things that are going on that you've mentioned in the service profile are things that you, the human operator of the cluster, are interested in keeping track of. So as soon as the service profile is created, Linkerd starts collecting statistics for us on all these requests. A third thing it does is that it can take a bunch of sort of more disjoint chunks of the URL space and combine them into one statistics bucket so that you, the human, don't have to do all the collation yourself. And finally, it can configure policies for things like retries and the like. Does that answer your question, or are you looking for more?
No, that was really helpful. Thank you.
Okay. So yeah, what we're going to do here is just ask Linkerd to go read the protobuf for the emoji gRPC calls and write us a service profile. This is what it comes up with. So This is a pretty simple one, really. It's just you can post to the list all service, or you can post to the find by shortcode service. Nothing particularly special. So we're going to go ahead and apply that to our cluster. There we go. And then we're going to do the same thing for the voting proto, because there are actually two different things going on. I'm not going to show that one. It's more of the same, but it's a little longer. So there we go. We'll apply that. That leaves us with the web service. The web service is a problem. Go ahead, Jason.
A quick interjection for those that are watching. So we posted some links in the Slack channel for the workshops. You can go view, now that he's created the routes, you can go view the status of those routes over at the route metrics tab.
And in fact, we're going to be doing that in about 30 seconds.
All right, sorry about that.
It's okay.
And we have a question from Ashish, actually.
HTTP fail fast. Fail fast is a little strange. I think, go ahead.
I was gonna say, do you want me to answer that?
Yeah, carry on.
So just a little bit, Ashish, about context. HTTP fail fast errors kind of represent the proxy doing what it's supposed to do. So depending on why that happened, you will get more information about it. And in general, creating a service profile and having route metrics will give you a lot more details about what's going on in your environment. The specifics of any one instance where you're seeing a fail fast error might be different.
It depends a little bit. I was saying that fail fast is a little bit weird because, yeah, it depends a lot on the context of what exactly you're getting a fail fast for. And so, yeah, happy to take that offline and talk more in Slack.
Thank you.
Yeah. So backing up to the web app, the web front end is not a gRPC service. It's, a web service that speaks REST and gRPC on the other end and things like that. But the things coming into it, not gRPC. We could go through and write a profile by hand for all of this, but we can also tell Linkerd to just tap the traffic coming into this deployment for a little while and then write us a profile based on what it sees, which is extremely cool. So what I'm going to do here is I'm going to hit return on this command. It's going to watch the traffic coming into the web for 10 seconds and then write a profile based on it. And this would be a great time for those of you following along at home to go to emoji.sivo.59s.io and then click on stuff so it's got a bunch of things to work with. There we go, 10 seconds starting now. And there we go. So let's take a look and see what it came up with. There's a way you can get the leaderboard, you can get a list of things, you can vote for a particular thing. You can go through and get JavaScript for the website. That's a little spooky. Somebody must have loaded this one right up front. So yeah, this is the service profile. Again, we could have written this by hand and come up with pretty much the same things, but especially if you're not the person who was writing the app in the first place, just asking Linkerd, hey, go and record the traffic and write me a profile based on what you see can be way more convenient. So let's go ahead and apply that one. There's that. And now I'm going to go over and share the dashboard. Let's see. So here's the dashboard. What we're looking at here is just all the namespaces. Since we're worrying about emoji vote, let's go and take a look at its namespace first. So we come over here. The first thing you'll see is you get this topology diagram. So we can see that there's this traffic generator that's feeding traffic into the web deployment, which is talking to voting and to emoji. Pretty straightforward. We can also come down here and we can see, oh yeah, look, we can immediately see that voting and web are having trouble and that the emoji and vote bot deployments are fine. So if we start with the web, up here on the top, we get this nice little graph of what's talking to what. You can see that some of these are nice and green and some of these are not, showing you that there's trouble going on. We can also scroll down here This is sort of our live view. But the really cool bit is you can click on route metrics and immediately see that, oh, look, hey, this one is having some trouble. API list is fine. So API vote, we figure is probably the voting deployment. So we can come up over here and click on deploy voting. Same thing, it will fill in the graph in a moment. Again, showing us red things where there are problems and green things where there are not. And if we click over the route metrics here and then sort by success rate, we can instantly see that donut is the one that's having trouble. Same information, whether you're looking at this from the command line or whether you're looking at it from the dashboard. But the dashboard, especially once you have service profiles in place, the dashboard is way, way faster. Any questions on this so far before we jump over and tackle another problem?
I've got one.
Shoot.
Just what's the implication? So if I'm a platform operator, right, and I've got apps running in production, what is the effective difference for me when I'm running, a meshed application with an intermittent error and I don't have service profiles versus when I do? Like, how does this change my life?
The biggest difference is that, well, basically you can't come over and just click on the route metrics tab and get an instant view. Instead, what you have to do is go through and run Linkerd eviz top, and then go through and wait for something to fail so that you can see the failure so that you know where to drill in. And depending on how frequently your intermittent failure happens, that might be a huge deal. You might be waiting there for months at a time if it's a really nasty one. Or, in this case, since every time you vote on a donut, it's a problem, it wasn't that big a deal to wait for it. But yeah, it gets to be worse and worse the more intermittent things are, especially when you're dealing with an app that has a deeper call graph where, you would have to go and pick each deployment and go through and look at it instead of having something a little bit simpler to work with.
Okay, so
does that make sense?
Is it fair to say, in summary, that having the service profile gives me the data in a way that is recorded and stays available, and I can look it up later?
Right.
Okay, that's awesome.
Yeah.
Oh, sorry.
No, I was just going to say, yeah. So Martin's question about service profiles affecting performance. Eventually, I think it's a pretty long eventually. It's not something that I would particularly worry about.
Yeah, you're more likely to run into an issue of too many services than service profiles.
Yeah. I would worry much more about the traffic running the cluster out of bandwidth, running the cluster out of steam before the profiles do, if that makes any sense. Ethan's asking about Buoyant Cloud. Let's come back to Buoyant Cloud at the end. All right. So basically at this point, we've gone through, oh yeah, let me show another thing here before we walk away from this one. If I flip over here to the live calls, and then let's see if we get a donut coming up soon. So I said a second ago that this is the same information that you see from the CLI. And in fact, there's one other thing that I want to make sure I show. All right, I'm not getting a donut. So we click on this microscope over here, and this will take us to a place where it's easy to run a tap from the dashboard. I'm going to cheat and skip over and replace this with donut, because I already know that that has a failure, right? So let's start that tap going. There we go. So if I click this disclosure triangle, there I get the same information that you could see from the JSON output, where you get to go through and point the developers to, right, here's the gRPC status, and here's the gRPC message, and all of that information also here with the CLI. Also here in the dashboard, as well as in the CLI. Again, they're both pulling from exactly the same data sources, and you can see the same things. So it really is up to you which one you want to use more. Okay. So yeah, at this point, we can be pretty confident that we have a smoking gun we can point the developers to, and we can go off and pat ourselves on the back for a job well done, which of course means that now is the time for something to go wrong with the Books app. Remember, still Friday night. We still are not terribly interested in spending lots and lots of time and waking people up unnecessarily or anything like that. The biggest difference between the emoji app and the Books app is that the Books app, we put service profiles in when I set up the cluster. So for the Books app, we can go and take a look at the routes straight away and just see route metrics immediately. And this one's a little bit more interesting because we can see here that, so these are failing about half the time. Trying to go through and edit a book, trying to go through and mess with a book are just half the time they're failing. That's not so good. So what else can we see here? Well, we can do the same sort of thing where here we can see we started from the web app and we can see that it's talking to authors. So let's go through and drill in just to make sure that everything is okay there and to kind of validate these 100% success numbers. If we look at that, then yes, okay, we do see that everything is fine across the board. So let's take a look and look from the web app over to the books deployment, sorry, the book service. All right, still failing about half the time. Also kind of interesting. And finally, to round it out, let's see if the books deployment is talking to authors. When we do that, we see that that's interesting. The books deployment is only doing one thing when it's talking to the authors deployment. And that one thing is failing about half the time. So that one thing feels like a place where we could probably start off and look a little bit. So actually, I kind of got ahead of myself a little bit there. Let's flip over and take a look at that in the dashboard. All right. Here in the dashboard, let's back up and take a look at the Books app. So again, we have a traffic generator talking to the web app. The biggest difference between the Books app and the Emojibodo app is that between books and authors, those two services are talking to each other, as well as the web app talking to them individually. And we can go through and repeat the same thing where we get to, we'll check out the authors deployment, we can look at the route metrics, and yeah, we see that this is failing. Again, failing, but only about half the time. If we look at some of our other deployments, the books deployment, take a look at its route metrics. Again, same information that we had in the CLI, but it's a little bit easier to deal with here and a little bit quicker because we have the service profiles in place. But the most notable thing here is that, let's go back to authors for a moment. When we look at the route metrics, so we note that this is a head request, and that's the only thing that seems to be having trouble. Head requests are interesting. They don't pass over any data, and if you repeat them multiple times, they should always get the same answer. They're idempotent. And if we look over at service profiles, Jason, do you remember I was saying service profiles could configure things like retries, and we would get to that?
I do, yeah.
Configure retries on your own services. For routes that are idempotent and don't have bodies like head requests, you can edit the service profile and add is retriable to the retriable route. So that gives us a potential way out here. I started all this by saying it was Friday night. We've found something that might be a problem in our application, but it would be kind of nice if we can just set this up so that the mesh can go through and make the problem go away and then deal with it on Monday morning rather than having to go and bug people late at night to get the thing fixed right now, right? So let's go and try that again. And what we're going to do here is we will go back to the CLI and we will do exactly what it just said. We will add is retriable true to the service profile for the books. This would be the service profile for the authors, the author service within the books app namespace. And all the way at the bottom, we'll find the head route. And we can literally just add is retriable true to that. All right, everybody cross your fingers. Now what we're going to do is we're just going to watch this from the CLI. We're going to go pull route metrics and just repeatedly do that so that we can see things changing. When we add -o wide onto the end, that will show us both the success rate of basically the success rate before the mesh gets involved, but it'll also show us the effective success rate after the mesh gets involved, messing around with retries and things like that. So if this worked out, we should see that effective success rate climbing, even though the actual success rate is staying the same. And in fact, we do see it climbing, which is kind of nice. We give it another second or two here to refresh. All right. Yeah, so that's headed towards 100%, as we would expect if retries were working. We can also go through and repeat that experiment looking at the web app talking into the books, right? Here it's already gotten up to 100%. I didn't stick -o wide, so it's only showing me the effective success rate. This is good because that implies that fixing that adding a retry to that one head request that was failing has fixed the entire application. There isn't something else lingering around in the bottom causing us problems. If we go ahead and look back at the dashboard for that, I apologize for the delays while I pick new screen shares here. We can still see that authors is having trouble under the hood, but we also see that the books app is now happier. So the dashboard still gives us a way to see that there's a real problem and to vet that we've fixed that problem from the user's point of view. So any questions about that?
None right now. For those that are looking to follow along, I posted up the link again in the Linkerd workshop Slack. So you can hop right over to this page and see what Flynn's looking at.
All right, cool. We have one more thing that I wanted to show. Getting back to the question from earlier about Buoyant Cloud. Actually, let me give you the bad news first. Buoyant Cloud is not something that's freely available. In a lot of ways, Buoyant Cloud puts a lot of effort into helping manage your installation as a whole. So it can do things like upgrades and manage certificates and things like that. For this talk, I'm going to point out a couple of things about observability, though. This is showing the cluster that I was playing with here. And so at this point, it's just showing me a bunch of top line stuff. The interesting bit comes when we go and look at the topology. So at this point, it's showing me the topology of all the applications, all the workloads in my cluster, which is not necessarily the most useful thing for us right now. But what is useful is that we get to zoom in, and we get to zoom in on multiple namespaces at once. So with that, we can look immediately and see, oh, look, this is our ingress. It can go through and talk to the web app. And there are a lot of paths here that show up in black, but there are a couple that are showing up not in black. That's where problems are. And you can just immediately go through with the cloud if you have all of these things hooked up. You can immediately go into this, just take a look at the things that you want to see and immediately see where there are problems. You'll also notice that this edge from the web app into authors is black. The only one that's still showing up as red over here is the one that actually is still having problems. The edge that is being affected by the retries is showing us that it's okay. So we know that stuff is going all right.
So Flynn, are you saying that even though you've masked the failure for your users using the retry, you're still seeing the underlying problem there reported? So you're not hiding the problem from your devs, you're just
exactly
masking the problem for users.
And maybe more importantly, you're not hiding it from the people in the NOC. You're not hiding it from the operators. You're not hiding it from all the people who need to be able to tell the devs about the problem so that they can go off and fix it. You're just hiding it from the users so that they're not complaining.
Awesome. Thank you.
Yeah. The other thing that I think is kind of fun about this one is that, you know, this is a graph. So you can actually walk paths through and see where the problems are likely to happen. It gives you a visual way of in some cases, being able to trace something all the way back and look at, okay, so, where is this likely to show up? What's it likely to happen? Martin asks if this wasn't previously available in the dashboard. It is. There's one important difference. I'm going to have to swap shares again for that. So here's the one important difference is if we look back here, basically, I get to see this for a single namespace, but I don't get to see it across namespaces. And I don't get the edges labeled and things like that. So this is a case where Cloud is able to do something of a better job than just Linkerd Viz due to the fact that it can go through and do some more of the higher level correlation for you. Does that make sense? And while we're at it, do we have any other questions?
I don't see any other questions yet. Martin, it'd be great to hear if that's a valuable answer. The way I look at it is just, it depends what you're doing, right? So the Viz dashboard has really good information, but it's local and it's somewhat limited, right? The Buoyant Cloud dashboard is able to view things at a much broader fashion, right? And it also has details that you're not going to see here, like report metrics, TLS status, things like that. Amruta, I'm sorry if I mispronounced your name there, asked, how do we calculate the P50 and P95 metrics?
I'm not sure how I should answer that. Are you asking what's the math behind P50 and P95, or are you asking the data sources?
We can answer that one.
Yeah, I mean,
it's
basically, yeah, 50% of the requests finish in under 3 milliseconds, 95% finish in under 44, 99 finish in under 89. There we go, data sources. And the data sources are the same ones that we get to see. Let's drill into one of these for a moment. It's basically all the same underlying data source. So here, the live calls, we get to see all the timings for this one because under the hood, we've got Viz keeping track of all of this stuff for us. Does that answer the question?
Well, just add a little bit more. The proxies, each individual proxy has a metrics endpoint that gets scraped. And so all the data is coming from the proxy endpoints, and then they're aggregated together based on their workload, right? So if you go back to the namespace view for a quick sec, go to Books app. So here, right, those P50, 95, 99 latencies are all based on the aggregated metrics from the proxies attached to those individual deployments. And then Martin says they remember seeing the broader view in Linkerd Viz. So that Linkerd Viz view that you're seeing here has been the same the whole time I've been at Buoyant. So it hasn't undergone any significant changes for at least the last year and a half. That's helpful. Sorry, Flynn. Please go ahead.
Nothing to apologize for. Anything else? All right, so I guess in that case, we can go ahead and wrap it up. Many thanks to everybody for joining from your various far-flung places late at night. We really appreciate it. Let me actually point out one other thing. A couple of things, actually. Can't believe I almost forgot this. So if you haven't heard about it yet, we've got KubeCrash, the KubeCon Detroit warm-up coming up. You can find that at kubecrash.io. It would be lovely to see all of y'all there as well. It's a virtual event digging into some more of the cloud native stuff, kind of digging into some more of the cloud native stuff before KubeCon so that you have an opportunity to go through and learn some things that aren't going to be necessarily coming up at KubeCon. Again, love to see you there. Check it out at kubecrash.io. And of course, This is the Buoyant Service Mesh Academy. We would love to see you next time for a deep dive into the upcoming route-based policy coming in Linkerd 2.12.
Yeah, and while you were doing that, we had two great questions come in from Martin. So Martin, would you recommend deploying a service profile with each and every app? I would tell you another Weasley answer like I did earlier. It's a bit of an it depends, but you'll see the case study from the folks at HEB, which I'll pull up and put in the Slack. You know, they do it, right? And they found tremendous value in profiling every single service that they deploy into production. And they had tremendous success with that. So it certainly can be very useful. Ashish asks, do you recommend using Prometheus as a separate source other than the one Linkerd Viz comes with? Yes, absolutely.
Oh, yes, 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 1,000 times yes.
We have a Linkerd production runbook, which specifically goes into all of our recommendations. So all of Buoyant's recommendations for running Linkerd in production. One of them is, you know, please set up and use a separate persistent Prometheus.
And this is a link to the runbook.
Thanks so much.
And yeah.
And then Adonai asks, when will this topology view be available in the dashboard? If you're asking about when will the things from Buoyant Cloud be available in the dashboard, there's no intent to make a significant overhaul to that. Yeah, there's no intent to make a significant overhaul for that. These products are separate and they do different things, right? And one is a commercial product specifically targeted at how do you view Linkerd in a holistic way across namespaces and across namespaces and across clusters. And looks like we've got the wrong link there for that Linkerd runbook.
I think it's a styling issue.
Sorry about that, Joaquin.
Thanks for calling that out. Oh dear. Philip on Slack says that they used the Linkerd prod runbook and it's really good, which is lovely to hear. Thank you very much. Let's see.
Oh, I think we're having a website issue there, Joaquin. So folks, sorry if you got the link and it's not working, but there's something happening on the back end. We'll get that fixed.
We'll get that tackled as quickly as we can. Anything else? We have a few more minutes if people want to toss out more questions.
Okay. Thanks so much, Joaquin. That was really, really helpful feedback. Yes, everybody, we really appreciate that. Your time. Oh, I'm sorry.
No, go ahead.
Yeah, we really appreciate your time. I'm gonna stop the recording here, and we'll see you next time.
Much appreciated.